Lesson 819, Are They Congruent? Rigid Transformations and Congruent Figures. In this lesson, we'll decide whether two figures are congruent in using rigid transformations, and more importantly, we'll understand whether congruent sides are enough to determine if two polygons are congruent. All right, we're on page 36. This is our last lesson before we have an assessment. So, like I said, we have two goals. Use rigid transformations. That's just translations, rotations, and reflections. Use rigid transformations to decide whether two figures are congruent. And I'm going to use my symbol for congruent again. And the other thing is understand whether congruent sides is enough to say that figures are congruent. Understand whether, use my symbol again, congruent sides in two figures is enough to call two polygons congruent. All right. Well, let's start with some basics here. To show that two figures are congruent, you can align one with the other using a sequence of rigid transformations. You can check that with transparent paper. And the distances between any corresponding points on those congruent figures should always be equal. Corresponding points. All right. So I think we've talked about rigid transformations and congruent figures a lot in the last couple of lessons, but we need to make sure we nail down how to know, or whether to know that there's enough information to say that figures are congruent. So we're going to explain why each of these figures is not congruent to rectangle A, B, C, D. So we have rectangle A, B, C, D. It's not marked, but it looks like these are right angles here. We have side lengths of 3 and 3, and the top and bottom are 5 units and 5 units. So I'm going to play devil's advocate here and say, well, this figure also has two sides that are equal to 3 and two sides that are equal to 5, so I think it's congruent. I would hope that somebody would come along and say, I understand where you're coming from, Mrs. Tuitt, but even though they have the same side lengths, it's not in the same order. And by same order, I mean that in our original figure, if I were going around, I would have 3, 5, 3, 5. And in this figure, we have 3, 3, 5, 5. So it's in a different order that I have those side lengths. And in addition to that, the angles are different. Angles are also different. If it were congruent, everything would be the same. So having the same side lengths isn't quite enough. So I try again. I'm going to play devil's advocate, and I was like, okay, well, here you go then. These are in the same order. 3, 5, 3, 5, just like that top one. All right, well, we have the same side lengths, but again, the angles are different. And in congruent figures, the angles have to be the same as well. If the original figure has 90-degree angles, then the transformed figure also has to have 90-degree angles. And last but not least, I could say, all right, well, here you go then. Here's something with 4 right angles, just like my original. But in this case, even though we have the same angle sizes, or same angle measures, the side lengths are different now. Here's 3, here's 4. And in congruent figures, all of the measures are equal, not just some of them. So because of these reasons, this figure is not congruent. If that's congruent, that's not congruent. This figure is not congruent to my original figure. And this figure is not congruent to my original figure. So just having the same side lengths isn't enough to say that figures are congruent. And if you're ever unsure and you want to check, we've said this before, but it bears repeating, you can match up the figures with patty paper or tracing paper. When you do that, you're essentially doing this next thing. You're finding a sequence of rigid transformations. To match the figures up exactly. So the main thing I want you to get from our lesson today is that just because some of the measures are the same in two figures does not necessarily mean that they're congruent. Good luck with the homework tonight.